Welcome back, everybody. We're going to get started with our third lesson of our unit scale factors and similarity. And basically, I just want to forewarn you guys that there aren't any practice questions for this particular lesson. And the reason for that is because this lesson is extremely similar to our second lesson, except for the only difference is now we're going to be dealing with three-dimensional objects versus two-dimensional objects. So basically, more or less, the steps are the same. Everything is kind of exactly what you've seen, but now just we're taking it on a bit of a different scale, more like real-life problems. If you're still having trouble after this lesson and you don't feel comfortable doing the homework yet or the assignment yet, you're obviously more than welcome to message me or email me and let me know of that. And then I will figure out something for you to get you a little bit more practice. But otherwise, here we go. So we're going to be discussing today a baker drawing a cake for a client that wanted one for their child's birthday. So the client wants it for their kid's birthday. And this cake was in the shape of a rectangular prism. The length measured 8 centimeters, and after having made the cake, the length measured 44 centimeters. So let me explain this to you. First of all, the baker had to draw the cake out for the client so that the client could say, yes, this is what I want, or no, this isn't what I want. Obviously, a baker is not going to go and make a cake and then have the client say yes or no. So when the baker drew the cake, when the baker drew the cake, that means that the length measured 8 centimeters. This right here is for the drawing. Okay, it's for the drawing. And after having made the cake, the length now measured 44 centimeters. So this is the life size cake. So that's the life size cake now. So what scale factor did the baker use? So basically, we have to determine two things. Number one, which object came first, and number two, which object came second. Once we do that, we can figure out our scale factor. Your scale factor is always equal to your diagram divided by your actual. Now, I had mentioned to you guys in the second lesson that you had to be very, very careful of this because this does not mean exactly what you're thinking, okay? So we're going to put a little note here on the side. The diagram actually represents the second object, okay? And that's very important for you guys to remember. You have to remember that. And then the actual object equals the first object. So the thing that was created at first. So we had said that the baker would draw it out first. So this is going to be your first right here. And this one's going to be your second. So then your scale factor is equal to 44 divided by 8. Now, we want to simplify that. And in a scale, you can have a decimal. So at this point, your scale would be equal to 5.5. Keeping in mind, a scale factor does not have any units at all. So your 5.5 means that was your scale factor that was used. Okay, so that means that the cake that the baker made after drawing it was 5.5 times bigger than what he originally drew on that piece of paper. Now, going off on the second question here, keeping in mind that we have that scale factor. So what was the width of the baked cake if the width of the drawing was 4 centimeters? So in this case here, what we're going to do is we're going to fill out the information we know and then what we need to find. So your scale factor is equal to your diagram over divided by, your actual. And so in this case here, we know that the drawing was the actual number. It was the drawing that it was what came first. So 4 centimeters in scale factor, we determined that was 5.5 equals your diagram, because we don't know that one yet. Oops, sorry, I misspelled that. Diagram divided by 4. Okay, so this comes back into the same sort of idea as to if your diagram was an X instead of a word, it doesn't really matter. It's the same concept. You have this divided by 4, so to get rid of this division of 4, we have to do the opposite. Therefore, we multiply each side by 4, and that means that 22 is equal to your diagram. But now that doesn't help. That doesn't explain what we're trying to find or what we have found. So we need to say the width of the baked cake is 22 centimeters. That's the answer to that. Now, if you'd like to pause at this point the video and try watching the second example, or sorry, try doing the second example yourself and then compare it to my answer, that would be a way that you can go and try some practice questions without me giving you any extras. But if you'd like to watch one more time and then try a practice question after by, like I said, emailing or messaging me for that practice question, you're welcome to do that, okay? So, a girl went with her mom to Tim Hortons to get a donut. As well as getting a donut, she wanted her mom to buy her a toy donut for her kitchen set at home. The diameter of the cooked donut was 12 centimeters, and the diameter of the toy was 4. So here's the thing. We have to figure out which one was the scale factor, but the problem is you need to know which one came first. So if you think about it, a drawing of a donut for Tim Hortons may have come first, but a toy donut for a kitchen set or anything like that, that definitely did not come first, because you have to actually make the donut and sell it before you can actually start selling Tim Hortons donuts to people for their toy. Okay, so this donut right here, it came first, and this donut right here, it came second. Okay, so scale factor equals diagram, which is your second, over your actual, which is your first. So this means that it is 4 divided by 12. Now, be very careful when you're doing this kind of a fraction. Do not want to give this as an answer. That is incorrect. Okay, so you want to give it an answer of 0.33. Okay, and the reason for that is because when we go to the next question, we need this scale factor, and so this gives us more precision than if it's just 0.3. Because remember, 0.3 is 3/10. It's not 4/12, which is equal to 1/3. 1/3 is not 0.3. It's 0.3 to the infinity. Okay? So on these kinds of fractions, you'll want to give yourself a few more decimals. So, now if the thickness of the cooked donut was 4 centimeters, what's the thickness of the toy? So this is where we start with scale factor equals diagram divided by actual. So in this case, we have 0.33 equals 4 over, oh no, I'm sorry. Yes. Yep. No. Oh my goodness here. Oh my goodness. Yeah. Sorry. Okay. We have diagram divided by actual. Sorry about that. So it's divided by 4 again. So in this case, you would multiply it by 4. And then multiply the other side by 4 as well. Focus here. There we go. And this gives us a total of 1.32 equals your diagram. Again, that's not enough information, so you have to say thickness of the toy donut is 1.32 centimeters. You must have your units when you're discussing something other than the scale factor. So I hope this helps, and like I said, if it doesn't, guys, you always know how to get a hold of me. Otherwise, good luck, everybody.